Hi, welcome to this Blender video tutorial entitled Bezier Curve and Circle, Loft Beveling Along a Path. Blender's Bezier curve objects can be redefined by the shape of another curve object. Blender refers to this process as beveling along a path. Generally, the beveling along a path takes on two different forms. In one, a closed curve shape is beveled along an open curve. In the other, an open curve is beveled along a closed curve shape. In this tutorial, we'll examine the former, beveling a closed curve along an open curve. Although Blender does not officially use the term, in many other 3D modeling programs, this is referred to as lofting. To demonstrate loft beveling along a path, I've modeled a Bezier curve object in the top view of my Blender scene. I have named this object Loft Path. I'll tab into Edit mode. Here you can see the simple Bezier curve arrangements of the control points and their handles. Note that this is an open B-spline. I'll tab out of Edit mode and place my 3D cursor below the Loft Path object. I'll then add a Bezier circle object. I'll name this object Loft Shape. I'll scale down the Loft Shape object a bit, and I'll tab into Edit mode and zoom in a bit. Note that the Loft Shape object is a closed B-spline. I'll tab out of Edit mode and select the Loft Path object. I'll click on the Object Data Context icon in the Properties editor. This displays all of the Bezier curve object controls. In the Geometry panel, I'll click on the Bevel Object box and select the Loft Shape object as the bevel object. This lofts the closed loft shape along the open loft path. The smoothness of the loft shape is controlled by the resolution of the loft path curve. Now by default, the resolution is set to 12 in the Shape panel. This is a good general setting. I'll reduce the resolution so you can see the effect. I'll return the resolution to 12. I'll tab into Edit mode and switch to Wireframe Display mode so that you can see the structure of the lofted object. Notice that the original loft path control points and handles are still available for editing. I'll tab out of Edit mode and select the Loft Shape object and tab into Edit mode and go to Solid Display mode. Notice that all of the original Loft Shape control points and handles are still available for editing. I'll tab out of Edit mode and reselect the Loft Path object. I have another closed Bezier curve shape named Bead Shape that I will unhide. I'll click on the Bevel Object box in the Geometry panel, press Delete, and then select the Bead Shape object as the bevel shape. There is another control box in the Curves Geometry panel called Taper. This allows a different curve object to control the taper of the original object. I'll place my 3D cursor below the lofted object and add a Bezier curve. I'll name this object Loft Taper. I'll then select the lofted object, and in the taper box of the Geometry panel, select the Loft Taper object as the taper object. The Loft Taper object now affects the tapering of the lofted object. It's easier to understand this effect, at least initially, if this is done in top view with the lofted object running along the XY axis. This is because the tapering effect is based on the relationship of the taper object to the lofted object along a perpendicular axis, in this case the y-axis. I'll select the lofted taper object and tab into Edit mode. The left end of the curve affects the left end of the lofted object in reference to its relationship to the lofted object along the y-axis. As I raise the left end control point, the thickness, actually the width, increases. The right end of the curve affects the right end of the lofted object in reference to its relationship to the lofted object along the y-axis. As I raise the right end control point, the width of the lofted object's right side increases. Raising or lowering both control points controls the entire loft object's width. However, this is an edit mode only relationship. I will tab out of edit mode and raise the loft taper object, and it will have no effect on the loft object's taper. I will tab back into edit mode. Note that the location in the X direction has no effect on the loft taper. I'll select the left-hand control point of the loft taper, hold my control key down, and left-click to create another control point. I will now adjust the loft taper control points so that the width of the lofted object tapers off from the center to either end. There is a variation of this modeling technique which Blender calls extruding along a path. To demonstrate this, I'll tab out of edit mode and hide the loft path, loft taper, and bead shape objects in the outliner editor, leaving the circle loft shape displayed. I'll then go to front view and add a Bezier curve object. I'll rotate this object 90 degrees around the x-axis and 90 degrees around the y-axis. I'll name this object Extrude Path. In the Geometry panel, I will add the circular loft shape object as the bevel object. This lofts, or if you prefer, bevels, the closed Bezier curve shape up along the Bezier curve object. I'll select the loft shape object and scale it down a bit. I'll then select the path curve and tab into edit mode. Note that I can adjust the control points and the handles of the curve object. I will use the 3D Editor Properties panel and set my 3D cursor to x, y, z equals 0. Then, with the curve object selected, I'll press Shift-S and snap the curve object to my 3D cursor. This will ensure that both the control points and my 3D cursor are all in the same plane. I will then select both control points and press Shift-H, making them both auto-handled control points. This technique works best, I think, if the handles are set to auto. I'll then select the top control point, and holding down my control key, I will left-click to extrude a new control point. This causes the closed Bezier circle object, which is the bevel object, to extrude up along with the new control point and handles. I'll continue to control left-click, adding new control points, and in essence, extrude the circle shape up along the path. This provides a very free-form method of modeling with a wide variety of shapes. I'll select one of the control points and press Alt-S. This allows me to scale any of the control points. The Alt-S scaling tool is available as long as there is no taper object assigned to the object. This Alt-S scaling also works on the lofting technique described earlier in this tutorial. I'll select one of the internal control points, and I'll press Shift-D and then left-click. This creates a duplicate control point and handle set in the same location. I'll then hold down my control key and left-click extrude a new control point. I can continue to extrude control points along this branch. As you can see, this is a good technique for tree-type objects, as it is easy to both branch to another extrusion and scale the effect. There is one final curve modeling technique I'd like to demonstrate in this tutorial. Just as a mesh object does not render unless it has a face, a curve object does not render unless it has a surface. Even adding a wire material will not render a Blender curve object without a surface. To demonstrate this, I will turn on layer 20, which contains a camera and some lamp objects. I will then hide the extrude path object and make the extrude path, loft path unrenderable. I'll then go to top view and make sure my 3D cursor is located at x, y, and z equals 0. I'll then add a Bezier curve object to the scene. I'll scale it up a bit along the x-axis. The camera is now focused on the curve object. I'll render the scene. As you can see, the Bezier curve object does not render. I'll tab into Edit mode, and I'll go to the Object Data Editor for the curve object. In the Geometry panel, I'll set the extrusion for 0.01, and then re-render the scene. As you can see, the Bezier curve is now rendered. Since it's possible to add colored material to a curve object, this is a very convenient way to model wire or string.